In this lesson, we're going to start trying to work our way backwards by looking at properties or diagrams or graphs of sinusoidal functions and trying to figure out the model, the equation that would make that happen. There are 4 things we need to be concerned about when building a sinusoidal model. First one is you have to figure out your amplitude. So if we know our max and our min, we can use the max minus min idea, divided by 2, now get us our amplitude. If we know how long our function is, the period, we can solve for k by using the 360 over k. A helpful thing when you're looking at a diagram is you could also figure out the horizontal distance between your max and your min. So for example, if we saw part of a picture, we knew our max was at 90 and our min was at 180, we could say those things are 90 degrees apart, or in other words, for the rest of the period, it would be a total of 2 times 90. 90 is your difference between here and here, right? And you can tell the period's 180. That's kind of handy. If you know half of the cycle, you actually know the whole cycle. If we want to find a vertical translation, our C value, again, we can use our max and min idea. So we're going to use it twice, C and A. We usually figure those 2 things out together at the very beginning because they're the 2 quickest things to figure out. And then the tricky one, the D value, the horizontal translation, left to right. So to do these ones, there's 2 things you need to think about. First thing I decide is, am I making a cos curve or a sine curve? Because depending on which curve we start with, cos curves are supposed to start at the maximum and go down from there. If instead it's over here and going down, well, then it's been shifted, obviously, that much to the right. Okay. Sine curves, on the other hand, start on our central axis and go up to the max, down to the min, and back to the central axis. So again, if you see that we're on the central axis, but it's over here now, goes up and down and back up again, there's been a translation. The tricky part with sine curves are, if we move them not just left to right, but also up and down, you start getting things like this. Well, then you have to figure out where the central axis is first. Figure out where you're starting on it and going upwards, going up. And that can be a little bit trickier to figure out, which is generally why we use cos curves as our starting point for a model instead of a sine curve. But we will talk about both. So let's start with a nice table. A table gives us all the information we're going to need without us having to go to find it. So if we talk about equation number 1, we'll do this first one right here, number 1. We need an A value, which we have, an amplitude. We have a C value right here. We have a D value, our left 45. So the thing we're already missing is K. And K is going to come from here. It's not 720 itself, but it comes from there. Okay. Remember the idea that our period equals 360 over K. So if I know the period is 720, I have an equation I can solve. We can cross multiply and then divide 360 over 720. Or in other words, it's 1/2. I wrote out the long way for a reason. If you notice, we started out at 720 equals 360 over K, and then eventually we got down to K is 360 over 720. So sometimes it might be handy to use the idea that K is always your period, sorry, not your period, always your 360 divided by the period. And it's just a rearrangement of this equation. And it helps us to figure out that K value really quickly. If we have all those parts and pieces, we can put our equation in order. Y equals A, my amplitude. I was told it was a sine curve in the question. My K value, we figured it was 1/2. Okay, a second bracket for my left and right. It's left 45, so I'll put it as a plus. And my central axis says 3, so it's gone up 3. And there's our equation. Nice and quick. Okay, we'll try the second one. So again, we have A. Okay, the C value is 0 this time. Our D value is right 120. The only thing I'm missing is my K. So my K will be 360 over the period, or 6. So go to the second one. Y equals A of 2. It says cos this time. Our K value we just said was 6. It's going to right 120, so subtract 120. The C value was 0, so I can put the plus 0 in there, or I can ignore that. And there's a really quick equation for us. Our challenge isn't going to be making the equation, it's going to be interpreting where do I get the stuff for the equation. So let's take a look at a picture. Pictures are really handy tools. Find out information. It asks us to make two different equations for the given graph. Now that could be two different cos equations, two different sine equations, one cos, one sine. We really get some choices here. Periodic functions are repetitive, so it could be about translations, a starting point. Or, because sine and cos are really the same graph, just starting in different points, we can use a different kind of function to describe it. Information that's important from a graph. We need to know our max value. We need to know our min value. We need to know how long the period is. So let's find one cycle. Now I know a cycle starts at a max and ends at a max. The min is the halfway point at 60 degrees. So to get back to the max, I need another 60 degrees. In other words, my period is 120. Okay. If I want to find A is my max minus my min divided by 2. Or in other words, 2. My C value is my max plus my min divided by 2. I got myself A and C. We know we can find K. K is our 360 divided by the period. Now I've got all the parts and pieces I needed except for my horizontal translation, my left and right. So I'm going to say to myself, what kind of function do I want to use? Y equals A. A is 2. Let's start with a cos curve. Cos curves, the very first point should be right on the axis and going downwards. Well, that point has been moved over here, 30 degrees to the right. So when I go to put that into my equation, I've got to put it as minus 30. Okay. And there's my C. But I also could have read that as, well, maybe the cos curve actually started over here. How many degrees to the right is that? Well, we said that's 60 more, so that'd be 150. So I could have written the exact same equation with more of a horizontal shift, minus 150 over there. Okay. Or, what else could I have done? I could use a sine curve. Now, sine curves are trickier because I have to think about the central axis. We said the central axis was 1. If I draw that on my graph at 1, my sine curve is supposed to start right on there, the very first point. Well, it's over here. It's been moved over to the right just a little bit. How much? Well, that's a little bit harder to tell. It's not exactly halfway between 0 and 30. It's slightly to the left of that. So sine curves, as you can see, are kind of more challenging to work with. So I'm going to stick with cos curves whenever possible. And as I did here, I got two different cos curves. Okay, just words this time. We got a seagull sitting on top of the water as waves pass. A wave passes every 4 seconds. The height of the wave from the crest to the trough is 0.5 meters. Sketch a graph over a 10-second period. So we know that the wave goes by every 4 seconds. So 4 seconds is a cycle, right? We only asked the graph to 10, but we can show what 4 seconds look like. The height of the wave from crest to trough is 0.5 meters. So we get a choice on our vertical axis here. We know the difference between the bottom of the wave and the top of the wave has to be 0.5 meters. But nothing says we have to start at 0. I could say my wave is 0.5 up to 1 if I wanted to. Or I can go from 0 to 0.5. Or I can go from 2 to 2.5. I don't know how deep the water is, so I have some choices here. Okay. We want to start a graph when the seagull is at the crest of the wave, at the top of the wave. So that means that 1 second, it starts, and it finishes again, and it finishes again, and it finishes again. And if halfway in between at 2, it should be at the trough of the wave. At 6, the trough of the wave. Oops, at 10, the trough of the wave. So when I make my graph, I get that. I'm just going to keep on going. And this is time, and this is height. Now again, I chose numbers here. As long as they're 0.5 apart, it doesn't really make a difference what those numbers are. Okay, determine a cosine equation to model the height of the seagull. So what parts and pieces do we need? Well, we need our max. Our max for my graph was 1. We need our min. Well, my graph was 0.5. The period, how long did it take to complete a cycle? 4 seconds. So I can figure out my A now. My A is my max plus my min divided by 2. 0.75. My C is my max minus my min divided by 2. 0.25. My K is 360 over the period, which is 90. Cosine curve is supposed to start first point at the maximum. Hey, mine does that. I have a perfect cosine curve. So no translation. A, 0.75. Cos. K, 90x. There was no translation, so only one bracket needed. And then plus C, 0.25. There's an equation. Nice and quick. I can get that pretty easy off that graph. Okay, let's look at a table of information this time. What can we recognize from a table? What are they giving us? Well, looking at this graph, I can see a max and a min. Okay. That alone gives me my A value. My C value. I can see that it's a cycle goes from 13 to 13. So I get my period, 720, which gives my K value. 360 over 720, you can just write that as a half. And then I got to figure out if there's a translation or not. Now this question asks for the function that's the simplest model. Simplest models have the least amount of parts and pieces in it. So if you were to stop and think about this graph for just a second here, it's telling us that at 0, we're at 13. And at 180, we're up to 17. And by 360, we're up to 19. And then back down again, right? Back down and then back down. Well, that kind of looks like a cosine curve. The cosine curve could actually go the other way. So really, what we've kind of made here is an upside down cosine curve. So if I think about it as being an upside down cosine curve, how do I do a upside down thing? I need a vertical reflection. So my A value, instead of being 4, I'm going to make it -4. That way, instead of starting at the max and going downwards, now I'm starting at the min and going upwards. And then I don't have to worry about any horizontal translations. I still have a K value, but I don't have any D. It doesn't have to go left or right. And there is the equation really quickly for that function. That's a pretty simple model. All I had to do was think about the fact that it was upside down instead of right side up. Okay, last one. A carnival Ferris wheel, the radius of 7 meters, makes a complete revolution every 16 seconds. The bottom of the wheel is 1.5 meters above the ground. Draw a graph to show the rider's height changes over time for 3 revolutions. Okay, so time. How long does it take to go along? Sorry, go around once every 16 seconds, right? So 16, 32, 48. And the bottom of the wheel is at 1.5 meters. Okay. The top of the wheel, think about this for a second. Okay, the bottom is 1.5. They tell us the radius is 7. So radius, 7. And the second radius, 7, tells me the top of this wheel is 15.5 meters above the ground. Okay. Our riders can get on this Ferris wheel at the bottom, We can go up to the top at the halfway point and back down again. Back to the top, back down again. Back to the top, back down again. And we'll get ourselves a nice periodic curve. Okay, the trick there is to recognize that the radius is actually giving us the height of that wheel, how high above the ground they are. Okay, find an equation for this graph. Well, what do we know? Well, we know our max, 15.5. We know our min, 1.5. We know the period, 16 seconds. Okay, we can find everything now, right? A, max minus min divided by 2 comes out to 7, which we already should have known because we said that the radius is our amplitude, and amplitude is a radius for a periodic function. But just to prove it, we can do that. Okay, C, max plus min divided by 2. That gives us 8.5. Okay, our K value, 360 over the period. That comes up to 22.5. Okay. Now notice again that this graph starts at the minimum and goes upwards. Well, we can make equations for that. I can make a cos equation really fast. All we have to do is think about this being an upside down cos curve. So instead of 7, we're going to make a negative 7. Cos 22.5. Don't have to worry about any horizontal translations because we're on the minimum value. Sorry, I forgot the x. And then plus C. And there's our equation. All right, part C asks us to predict what's going to happen to the graph and the equation if the Ferris wheel turns more slowly. So what would happen to this? Would it change the height of the Ferris wheel? No. So A won't change, C won't change. Amplitude and axis. But what will change is how long it takes to go around each time, which is going to change the period. So our graph, the graph would be horizontally stretched. Okay, and that would change which value? K. The K value, if you're thinking about this as being 360 divided by a bigger number, the K value would get smaller. Okay, and that's where we can create some models. So that's the end of that lesson. Try some things. You got to be able to figure out different parts and pieces of equations by looking at different sets of information. Tables, graphs, words, things like that.